Today's lesson is on periodic trends. So if you remember, the periodic table is divided into 18 groups. This is group 13, 14, 15, 16, 17, and 18. And we talked about valence electrons. And those are the electrons in the outer shell of each atom. So those in group 1 have one valence electron. Group 2 has 2. Those in 13 have 3, 4, 5, 6, 7, and 8. Remember, the noble gases have 8. And everybody wants to achieve a full outer shell, which for most atoms is an outer shell of 8 electrons. Okay, so now that we've reviewed that, let's talk about the 4 major trends, 4 major periodic trends. They are atomic radius, ionization energy, electronegativity, and electron affinity. So we are going to take a look at each of these individually as we go forward. So first of all, we have atomic radius. Atomic radius follows a different path than all of the other trends. So atomic radius increases as we go to the left and as we go down. This means that what we call the big corner, where the biggest elements are, is going to be here. And the smallest are going to be here. So remember, radius is just the size. We'll talk about the radius of a circle relative to the size of the circle. So it's the same thing when we're talking about atoms. It's how big the atom is. So those in this bottom left corner are going to be bigger than those in the top right corner of the periodic table. So atomic radius, just to clearly define that, it's the size of the atom. Okay, then we have a trend called ionization energy. Ionization energy is the energy required to remove an electron from an atom. Okay, so this one's going to follow the opposite direction. This one's going to increase as you move up the periodic table and increase as you move toward the right. So what that means is our big corner is going to be here for this one, and your small corner is going to be here. Okay, so what that means is those atoms with the lowest ionization energy are going to be found here, and those with the highest ionization energy are going to be found here. One more quick note. Ionization energy. Noble gases have the highest. I'm going to abbreviate ionization energy as IE here. They have the highest ionization energy because they have a full outer shell. What that means is it's really hard to take an electron away from a noble gas. So it's hard to remove their electrons. Therefore, it's going to require a ton of energy to take them away. Okay, so now let's talk about our third trend, electronegativity. Electronegativity follows the same path as ionization energy. Increases as we go up, increases as we go to the right. So once again, those with the highest are going to be here in our big corner, the highest electronegativity values. Those with the lowest are going to be found in this corner. Okay, there's a trick to this one though. Noble gases have no values for electronegativity. Why is that? Well, electronegativity is defined as the tendency of an atom to gain electrons. So the tendency of an atom to gain electrons. Well, remember, the noble gases have a full shell, so they're not going to gain any. They're not going to gain any electrons. They don't want any more. They have the perfect number. So therefore, they have no values here, whereas for ionization energy, they had the highest values. So those are a little different there. Just a reminder, the little E negative represents an electron. Okay, our last trend, electron affinity. Electron affinity is defined as a change in energy when an electron is added. Electron affinity, once again, follows the same pattern as the previous two trends. It increases as we go up and to the right on the periodic table. So we have our high corner here again. We're going to see the highest values, lowest corner here in that same spot. So you're going to see the lowest values represented here. Highest values represented there for electron affinity. Okay. So let's take a look at these all together. Ionization energy, electronegativity, and electron affinity. All of those follow this same path. They increase as we go up and increase as we go to the right. Well, if they increase in those directions, if I asked you in which order they decreased, it would just be the opposite directions, just to clarify. So that means overall, this is the direction that those are going to increase. The difference in those three is ionization energy has the highest values are the noble gases. Remember, noble gases are in group 18, the last ones represented there. Electronegativity, fluorine is the highest. Little strange trick here, but for electron affinity, chlorine is actually the highest. And that's just because of a weird relationship with fluorine. So once again, if you notice the noble gases, okay, they don't really count for these two. No noble gases, but the noble gases are super important for ionization energy. Okay, last point here. What is our opposite trend? Atomic radius, the size of the atom. So remember, that follows the opposite trend. Okay, so we get an increase in size as we move to the left and an increase in size as we move down the periodic table. So the overall trend that it follows is this direction. Quick note on atomic radius. There's also something called ionic radius. I want to talk to you a little bit about what those are. But first of all, let's talk about why the size increases this way, because it's a little different. So as we move to the left across the periodic table, we have fewer and fewer and fewer electrons and fewer protons overall. So we have less, what matters the most here is the change in the number of protons. So as we have less protons, remember the protons are represented by the atomic number. So as we have less protons, as we move this direction, we have less of a force between the protons and the electrons in that outer shell. So we're not seeing those as much as we would. So we don't have as much force pulling on it, which means that atom is going to be larger. As we're over here on this side, we have more force pulling.